Hi, everyone. All right. Is this mic working? So we are completing then our lecture on Plato's Republic, Book 7. And we have been through the cave allegory, and we are moving on to the second part of Book 7, which is the education of the philosopher. So what Plato is outlining here as it is the program to educate someone to become a philosopher, but also the education that teaches us to realize that reality lies in the realm of the forms, in abstract ideas, not in the physical world. It is the education that teaches the nature of the forms in general. And so we're going to go through this relatively quickly, but a little comment on sort of how this works in general. The cave allegory progresses in a stepwise fashion, as they say, right? Meaning that in order to convince the prisoner in the cave that the external world outside the cave is more real than the world in the cave, you have to sort of wean a person off of their illusions and slowly introduce them to the truth. And so Plato's education program is going to follow that model. Right? The education is going to be like dragging someone out of the cave. Now, yeah. So this educational model is what was taught at the academy, Plato's academy, and it is roughly still what we call an academic education. In general, it works by progressing from the concrete and particular to the universal and abstract. Now, as it progresses from the particular to the abstract, it grows in significance, the things that are learned about. So let's just go into it then. Education begins, Plato says, with physical education. Right? We remember that this is all in the context of this tripartite structure of the individual, where the body is the bottom rung, the spirit is the middle, and the mind is the top. So as we move through education, we want also to move away from the physical and toward the intellectual. So we start with physical education, right, with gymnastics and learning how to use your body correctly, right? But that isn't really education properly. But it's interesting, nevertheless, that Plato begins with physical education. I think just to sort of acknowledge the necessity of physicality, right? What we begin with is knowledge about our bodies. What everyone sort of readily takes to is learning how to use your body, learning how to do exercise, get in shape, that sort of thing. Play sports, right? Everyone likes to play sports. Everyone wants to be good at sports. Everyone wants to learn how to be good at sports. There's sort of a lower threshold to enter that kind of education. Anyone can learn. It's not difficult in the same way that other kinds of education are. So we begin with physical education. This is our starting point. But the proper education, the education that Plato is most concerned with, begins with mathematics. Famously, above the entryway to Plato's Academy, there was a sort of plaque. There's a proper word for it, I can't remember. An inscription that read, "None but geometers will enter," or "Let none who are ignorant of geometry enter." The idea being that in order to get into Plato's Academy, in order to learn philosophy from Plato, you had first to have an education in mathematics. So the bulk of the educational program that Plato lays out here is in mathematics, and we're going to attempt to give a reading of that, interpret how this mathematical education works. So the first education, the first mathematical study that Plato assigns, there are 5 mathematical studies that make up the core of Plato's education. The first is arithmetic, right? So what is happening in arithmetic, right? Arithmetic teaches us to see the world slightly abstractly, right? In the following way. We see objects, right? And we call them by names. And we say that they are the thing that they are. We have a glass here, right? But I can abstract away from that individual thing to strip that object of any of its content or character and say that this is not a glass, it is a one, right? A unit. And this, right, assigning numbers to things is universalizable, right? It shows that everything can be abstracted, can be turned into a contentless form of some kind. Now, the numbers are not forms per se. That's a whole controversy we don't need to get into. But just the process of identifying an object as a one is an abstraction. And it shows that the abstract nature of the thing can produce some kind of result, right? What's more, we see in arithmetic a certain kind of certainty, right? We see in arithmetic an immutable truth, a truth that is true in all cases, regardless of circumstances, right? 1 + 1 is 2, no matter what those one things are, right? So a glass and a book, a table and a lamp, just naming the things that are surrounding me. All those things, what the thing is, the particularity of the thing in question isn't ever going to change the fact that when it's reduced to its oneness, viewed as a unit and added together with another unit, those 2 individuals will make 2. And so mathematics shows the nature of absolute truth and the way that to begin to get at that absolute truth, you need some abstraction. And so we take with arithmetic one step away from the purely physical. It's still connected to the physical, right? Numbers refer to individual objects, but it's abstracted away from the particularity of that specific individual. So arithmetic sort of primes us to think of things in abstraction and shows us that in that abstraction there is more this certain truth, a truth that is eternal and unchanging, and is outside of the changing physical world, right? The physical world which is constantly changing. So, having mastered arithmetic, then we move on to geometry. We move on to two-dimensional geometry. And here we discover that this sort of principle that abstraction produces certainty grows even stronger. And more importantly, we see that what makes a thing is not anything to do with the particular characteristics of this specific individual example, but rather the principles that apply to every example. So I can have many different triangles, many different right triangles, right? Right triangles on different sides of different sizes, positioned differently, right? I can have an enormous right triangle and a very small right triangle. I have one lying on the hypotenuse, one lying on the base, whatever. All of these different triangles, what makes them all triangles, what makes them all right triangles, is that they possess certain characteristics that are common to all of them. What makes them triangles is not their size, not their position, not how they're oriented. What makes them triangles is instead an abstract principle which applies equally to all of them. And this abstract principle is going to be a more complicated kind of truth and more complicated kind of principle than we got in arithmetic. It's going to give us more information about what a thing is. So I will see that all right triangles have a 90-degree angle, right? And that all of their angles, the sum of their angles will be 180 degrees, right? That is true of all right triangles. I will see eventually that the Pythagorean theorem exists and applies equally to all triangles. So that what makes any individual right triangle a right triangle is not anything having to do with its particularity, the fact that it's an individual, or that it's in this or that place or has this certain dimension, has certain dimensions. Rather, what makes it what it is something that is only an intellectual principle, something that's not precisely visual, not precisely experienced as part of the triangle, but can only be gleaned through thinking. And we see that the definition of a right triangle comes through the form of a right triangle, a form that is present in every right triangle. And so with two-dimensional geometry, we see that the definition of a thing is also abstract, universal, and unchanging from one example to another. So we get a higher degree of abstraction. Right? The Pythagorean theorem is more abstract, requires a higher kind of thinking than merely calling an object a one, right, making it a unit. It actually gives the thing its character, makes it what it is. It determines the rules that govern this thing. And so the rules that govern triangles are not visible, not physical, but intellectual. Right? Next, we have an interesting moment. A moment in the text that indicates that the importance of these, the progression, the movement from one study to the next is not arbitrary, but is planned and intentional. And this is a moment where Socrates introduces one mathematical study, which is astronomy, and then goes back on himself and says, no, wait, we forgot one, right? And here he is indicating that there is a natural and proper order to studying these things, that the nature of these things gives them to a particular order, and that we have to discover the correct order of education based on the nature of things themselves. So Socrates cues us into the fact that there is a proper order here by introducing something in the wrong order and then going back and fixing it. So after two-dimensional geometry, we move on to solid state geometry, or three-dimensional geometry. And this is where we move not just to a higher degree of abstraction, but also we move from sort of a flat world of points in arithmetic and two-dimensional shapes in flat geometry into the physical lived world of three-dimensional objects. And here we see that three-dimensional objects, just like two-dimensional objects, are defined by certain unchanging abstract principles, that there is a intellectual principle that governs the physical world of three-dimensional objects, right? That the way to figure out the volume of a cylinder is always the same, regardless of the cylinder, right? The way to figure out the density of a cube can always be the same. So what is happening in this move is we move into the three-dimensional world. We see that the things that we actually interact with, that the environment that we move through, is itself also governed by mathematical principles, right? That there is an intellectual structure to the physical world, that what governs the physical world, what gives order to the physical world, is abstract and intellectual, and at this point, mathematical. The next study that we progress to is astronomy, right? And here again, we get to yet a higher level of reality. Not only are the three-dimensional objects on Earth governed by mathematical principles, but so are the stars in the sky, the sun and the moon, right? That there is a mathematical pattern to the way the stars move, right? There is an order to them, and that the sun and moon also follow an intellectual principle. And so not only is Earth governed by an abstract mathematical principle, but so are the heavens, so is the solar system, the stars, etc. Right? So with this, we see everything in the visible world, everything that appears, right? What makes it what it is not its appearance, but the idea behind it, right? The intellectual principle that orders it. So before we get to the final mathematical study, I want to mention that, right, this mathematical principle is that we discover through the study of mathematics is not maybe per se a form, in the sense that there's a form of piety or a form of justice, but rather shows that truth and the reality that we live in is not what appears to us, but what we're able to see intellectually, right? I don't see in the triangle, in the right triangle, that its angles have to add up to 180 degrees, right? I can only get there through rationality. I can only arrive at the principle that all right triangles have angles that add up to 180 degrees through intellectual thought, right? Through thinking. Nothing about an individual triangle or even any collection of triangles can tell me that all triangles, all right triangles are this way, right? That leap to the universal is an intellectual one. And that reality is arrived at intellectually. But nevertheless, it is the intellectual principle that is more real than the physical thing, right? Because it's the principle that makes the physical thing what it is, right? The appearing triangle manifests itself as having 180 degree angles. But it's not because of its physicality. It's because of the principle that it represents in its physicality. So we can see that this education is pulling us away from the physical and toward the intellectual, right? Toward the non-physical. And that what we get when we move out of the physical and the realm of appearances and into the realm of ideas is a structure, set of principles that are unchanging, eternal, and non-physical, right? Without any kind of physical characteristics. So the reality that underlies all of the appearing world is unchanging, absolute, and eternal, right? So this is analogous to being pulled out of the cave and into the light, being pulled from the realm of appearances, the realm of opinion, and into the realm of forms where we can have true knowledge, knowledge that is stable, unchanging, is of eternal things. And so then we get to the final mathematical study. And this is, I think, the most interesting one. Right? And this is the study of harmony. So why does Plato include harmony? Why is harmony the last example, the last mathematical study? Harmony concerns not what is visible, but what is audible, right? And sound is itself sort of right on the border between the physical and the non-physical. Sound is a vibration. It is an appearance. It can be misleading. It is changing. It comes into and goes out of existence. So it is an appearance. It is in time. But it isn't something that you can touch or see. It's right on the border between the visible and, or rather the physical and the non-physical. It is the furthest limit of the physical realm, right? So sound, we might think, might not be structured according to mathematics the way that visible things are. We might think that sound is something different. We might think that there are parts of the world of appearances that are not governed by mathematics, not governed by abstract principles. So Plato wants to show, or wants to have the student recognize and learn as the last mathematical study that, in fact, sound is organized mathematically. That harmony, musical harmony, is a question of mathematical intervals, right? That in order to produce harmony, in order to make sound beautiful, in order to give sound any kind of structure or form, it has to be and can be organized according to principles and mathematical principles, right? So the way that you make an instrument, for example, is by applying mathematics to sound. Like the frets on a guitar or the length of the strings of a piano are mathematical measurements, right, that can structure sound in such a way as to make harmony. So that sound also is governed by mathematics. But what's also interesting about the example of harmony, besides the fact that it's this sort of threshold between the physical and non-physical, is that we see in the example of harmony that what structure gives us is not just the truth of a thing, not just the principle that governs it, but that this principle is also what makes things beautiful. So harmony shows we could say, horizon of the non-physical, and also points to the idea that not only is principle, logic, and truth based in something abstract, but that beauty is also something abstract, something that is derived from a principle. Now, so those are our 5 mathematical studies, right? Arithmetic, 2-dimensional geometry, 3-dimensional geometry, astronomy, and harmony. Having learned all those, we can then finally pass out of mathematical studies into a study of philosophy proper, into a study of what Plato here calls dialectic. Now, dialectic philosophy is not going to be mathematical. Philosophy is something more than simply mathematics, studying mathematics. Philosophy is the study of the good, the just, the beautiful, and the true, right? Those are the highest forms, the highest ideas that philosophy seeks to understand and that Plato is concerned with. So why do all these mathematical studies prepare us for this kind of philosophical investigation, an investigation of the good, the beautiful, and the just? The implication is that just as every individual triangle is a triangle by virtue of participating in some in this intellectual principle, this intellectual definition of a triangle, it's also true that everything that is genuinely good in the world, everything that is valued as good or should be valued as good, is also governed by an organizing principle, an organizing idea. And each example of something good is an instantiation, an instance of this governing principle, governing idea of the good. And that is the form of the good in itself, that which is good in principle, which is independent, objective, absolute, and like all mathematical truths, is unchanging and eternal. This is the object of philosophical thought. Now, this again relates back to the allegory of the cave. Remember, at the end of the allegory of the cave, the prisoner learns about the sun and learns that the sun is the cause of everything in the visible realm. Right? The sun is the cause not just of that which is outside of the cave, but also that which is in the cave. The sun is the cause of everything in the physical world. It organizes and governs everything in the physical world. Analogously, we can say that philosophy and the philosophical idea of the good, the form of the good, is what governs and organizes everything in the intellectual world. Right? We have the realm of appearance, the realm of forms. In the realm of appearances, the sun governs everything. In the realm of the forms, the good governs everything. Now, the allegory of the cave works in two ways, right? One of the ways it works is as an allegory about the relation between the physical world and the intellectual world, the realm of forms and the realm of appearances and the realm of forms. What we see from the allegory is that which rules the realm outside of the cave, the sun, also rules the realm of illusion within the cave. And so we can extend this to say that which rules in the realm of the forms is also what is going to rule and govern within the realm of appearances. So that the good, which rules the realm of forms, is also that which rules the realm of appearances. So the good is the cause of everything. When you go through the mathematical studies, when you then study philosophy, this is like being dragged out of the cave. Learning the form of the good, learning to contemplate the form of the good, is like learning the nature of the sun. It is learning what is true in both the intellectual realm and the physical realm. So it's not the case for Plato that your idea of truth in the cave is just as good as your idea of truth outside of the cave. Because once you know the form of the good, you can not only explain why something is good, right? Explain the cause of goodness, right? That thing that Euthyphro couldn't do about piety, couldn't explain why something is pious. So you can explain why something is good, but then you can also explain why someone thinks something else is good. You can explain wrong opinions and illusions about the good. So those who have mere opinions about the good, illusions about the good, can't give a good answer for why something is good, and they won't be able to explain any other idea of good but their own. Whereas someone who doesn't have an opinion about the good, but has knowledge about the good, the form of the good, can both explain the cause of all good things and why people are mistaken about the good. Explain the difference between illusion and reality or truth. So this is the point of education, ultimately. Right? Now, this final point is the contemplation of the good. Is dialectical. It's philosophical. Whether or not there is a principle of the good in the same way that there are principles for a right triangle is an open question, right? Plato doesn't come out and say. Just like in the Euthyphro, he wants to leave some questions unanswered. He wants to seduce the reader into thinking about these things. So whether or not the good is something as certain as the Pythagorean theorem is unclear. My own interpretation is that that is not the case. The good, because the good is dialectical, it is something that must always be contemplated, that we can never come to a perfect understanding of, and that we must always sort of be negotiating, wondering about, and having dialogue about, having discourse around. So that the job of the philosopher is not to know the good necessarily in its completeness, but to be able to distinguish the characteristics of the good, be able to distinguish knowledge from illusion, and then be able to debate what is going to be good, right? What the good will be in a certain situation, in a political situation. So that the reason you would want philosopher kings to rule a state is not that they will necessarily always be right or know precisely what to prescribe and always what to do, but they will have the right method for deliberating, thinking about the good, thinking about the relation of the idea of the good to reality. So we've been sort of saying that Plato is this, thinker who believes in a sense of absolute good, right? That the good is good not because someone decides it's good, but because it's good in itself, and that's true. But it's not clear if Plato thinks that you can know the form of the good exhaustively, right? That, in fact, to be good and to do good, you have to constantly be contemplating the nature of the good, the form of the good. And that this is what the activity of philosophy is, right? To constantly try to explore that idea of the good more. All All right, so I'd like to go into transcendence, but we don't have time, so we'll leave that for another video or our discussion. All right, until next time.